Okay, and then for the chapter 4, you can turn to the chapter 4 because we have one last chapter, which is the integrations. What you need to do is that the integrations, so it's in fact the oppositions of differentiation. Oppositions of differentiation. In the chapter 3, we know how to do differentiation, 即係用微積分. But now you have to use the integration, which means it's the opposite. Okay, so what you can see is like in the examples, you write the following and integrate integrals notations. So first of all, if we d like here example a d the x to the power 5, so you know the answer is 5x to the power 4. So when we do the opposite, well, this is differentiation. When we do the opposite, we integrate. This is the integral sign. So this is integral sign. And then we have 5x to the power 4, which means the same here. If we do the reverse, so you will write integral sign in front and then dx at the back. Okay, so the answer will be exactly x to the power 5. But please make sure that in the first part, we have to plus c in here. So what it means, the plus c, is that we have the plus constant. The reason why we need to add the c, because if we dx to the power of 5, we know we got 5x to the power 4. But the same situation is that if we dx to the power 5 plus c, because if we d the constant, it will got 0. So if we do the same things, 5x to the power 4, if you do integration, so you will say x to the power 5 plus c. So just write down plus c at the end. So you don't need to care about what is c means. Just write plus c at the end for the answers. Similarly, if we d e to the power of x, if we d e to the power of x as the lecture 3, we know the answer is e to the power of x. So if we integrate the same, okay, you will write down e to the power of x plus c. Okay, just write a plus a constant. So how can we get the answers by integration? So you can turn to like the page 2, methods of integration. So directly jump to here, you will see that we have several ways to do the answers. For the part B, fundamental integrations by formulas, so we can follow 6 rules. Rule number 1, if you integrate k to the power k, so that means we are going to do the first step, which is to integration of constant. Okay, if we integrate the constant, the answer is kx plus c. Okay, remember not to make confusions for differential integration, okay? Because if we in the k, so it will be kx plus c. So to check the result is, if we d the kx plus c, okay, the k is a constant, you take it out, and then if we d a constant, it will be 0, so the answer is k. Okay, so in fact, if we do the reverse, if we in the k, so you can get back kx plus c. So the example is, if you integrate the number 1, so it will be 1 times x plus c. If we integrate the 4, it will be 4x plus c. If we integrate 4 over 3, so the answers will be 4 over 3x plus constant. That is the first rules. Okay, and then for the second one, we have the power rules, which is the integrate of x to the power of n. So if we integrate x to the power of n, the answer is x to the power of n plus 1. And the last is that you are going to divide by n plus 1. The thing is that if we check, we can do the checking. Just like here, if we're going into details to differentiate this one, so you can actually d the function by take out 1 over n plus 1. Okay, and then you are going to d the x to the power of n plus 1. This is to d this part. If you d the constant, it will be 0. Okay, so finally, okay, because if in chapter 3 we put n plus 1 in front, and the power will be reduced by 1. So you can see why we need to have an n plus 1 here, because we can cancel out each others to get x to the power of n. So if we do the reverse case, is that if it is integrate x to the power of n, so the answers will be x to the power of n plus 1. In fact, the power increased by 1 and then divided by n plus 1. And finally, plus c. The case is that we can see the example 1 here, integrate x to the power of x, so the answer will be x to the power of x plus 1, and then the power increased by 1 to becomes 9, and finally divided by 9 and then plus c. 1 over x to the power of 4, so you change the function to be x to the power of minus 4, and then the minus 4 plus 1, it will becomes minus 3, and then finally divided by the new power minus 3, and then that is the result. So similarly, x to the power of, say like here, this one, x to the power of 4, and then square root power of 5. So as I said in chapter 3 many times, it will be 4 over 5 for the power. So afterwards, the result is 4 over 5 plus 1, and then divided by 4 over 5 plus 1. So the answer is x to the power of 9 over 5 divided by 9 over 5. So it will becomes 5 over 9 times x to the power of 9 over 5 plus c. And that's it. Okay, so that completes the first two rules. And then you can take a look into the page number 3. Page number should be page number 3, the rule number 5 and 6 first of all. So this time, if you integrate the polynomials, so it's integrations of polynomials, and then what you need to do is to integrate the terms one by one. Okay, so say for example, I do it in my own way. So for example, if we integrate this one, okay, so the first part is to integrate x squared, the other is to integrate the number 1. Okay, and then what you need to do is that just follow the rules, x to the power of 2 plus 1, and then 2 plus 1. Okay, for the 1, it means 1x. Okay, so just add the x here, and finally plus a constant. So x to the power 3 over 3 plus x plus 3, and that is the result for the rule number 5. And what we can continue is that you can continue to the rule number 6. The rule number 6 is to integrate constant. Integrations of constant multiple of fx, a function. For example, if you integrate 6x, you just need to take out the 6, just like here you take out the k outside, and then it will be 6 times integrations of x. So while you integrate the x, it will becomes x squared over 2 plus c, and then finally 6 and 2 cancel out to become 3, so 3x squared plus a constant. So 12 times square root x, so take out the 12, and then 12 times integrals of x square root, and then the x square root is like well, right here. This is in fact power 1 over 2. Okay, because the square root x is 1 over 2. So 1 over 2 plus 1, and then here is 1 over 2 plus 1. So the answer is 12, and then which is 3 over 2, and then this is x to the power of 3 over 2, Okay, and then the answers is that it will becomes the answers of 8, because it's 12 divided by 3 over 2, it becomes 8 to the power of 3 over 2 plus c. Okay, so that is why the answer is like here. One more example for it is like negative 12x to the power of 3 maybe. So take out the minus 12 and then you in the x to the power of 3. So it will become x to the power of 3 plus 1 and then 3 plus 1. Okay, so it is 12. Sorry. So it's like here. Take out negative 12 in x to the power of 3. And then if you integrate, the power becomes x to the power of 4 and then over 3 plus 1. So it will becomes x to the power of 4 divided by 4. And then cancel out, it will become minus 3, x to the power of 4. And finally, just add up the constant. Okay, so at the meantime, so do remember to try the exercise like 1 to 17.